we go. All right, so negatives. Pause the video and write that down. Okay, here we go. Sorry about that. Example 1. I'm really glad I checked. Okay. Create a table of values for the base function and then shift, identify the domain, range, and horizontal asymptote. All of these things, domain, big D, range, big R, horizontal asymptote, HA. You don't have to write the words, but you can. Yesterday, we graphed functions that basically looked like this. 2 to the x plus or x minus 4 minus 5. Today, our functions have a number in front. Okay? The nice thing is this number doesn't do anything, we don't have to do anything different. Okay? The only thing it's going to change for us is, I'm going to use orange because I like it. Our box now, just like yesterday I said, box your base. We get to include that number in front in our little base box. All right, so we have our base box here. And just like yesterday, what does the x minus 4 do to the graph? Right 4 units. Perfect. And what does the minus 5 do to the graph? Down 5. Very good. Write that down. Every number in our function has a job to do. The nice thing is this number in front we're going to take care of with our little XY chart. And whether it's a vertical chart like this or a horizontal chart, doesn't matter. So I'll do one of each. So the next one I'll do a horizontal chart. Just like yesterday, what are some good values to choose for x? 0 and 1. Always. They're the easiest numbers to think of. So let's see what happens here. When I plug 0 into my base box here, 3 times 2 to the 0. Okay, now, what is that?
1.
Nope. It's 3. Very good. Why is it 3?
Because 2 to the 0 is 1 times 3.
That's right. We have to do the exponent first.
Oh.
2 to the 0 is 1 times 3 is 3. If you're not sure, what can you do? Use your calculator, ladies and gentlemen. This is why we have them. I don't know if you noticed. Will you take a look at your calculator? Take a look at your calculator. You want to go back to the home screen. You're going to do second quit. Second quit takes you back to the home screen. Okay? If you're in your graphing window, you can do second quit. Look up at the screen. Okay, now you can type that in. 3 times 2 to a power of 0. And you can see that the calculator agrees we get 3. Okay? All right. Now let's plug in a 1 to our base box there. 3 times 2 to the first. Okay, let's try it without the calculator. What do you think the answer is? 6. Very good, ladies and gentlemen. We get 6 because 2 to the first is 2 times by 3? 6. Okay? And again, maybe you're not sure. What can you do? Use your calculator. Okay? All right, let's plot that little base graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So in orange, I'm plotting my base points here, 0, 3, and 1, 6. It's a little off my graph, but that's okay, no big deal. Just float it up there. Ladies and gentlemen, is this exponential growth or exponential decay? Growth. It is still growth because the base is 2. And so this graph just still looks like a Superman graph. And now we're going to go ahead and shift it. How are we going to shift those orange dots? Right 4, then down 5. Very good. So we're going to go right 1, 2, 3, 4. Down 1, 2, 3, 4, 5. Beautiful. I'm going to shift that other orange dot. Right 1, 2, 3, 4. That's hard to do. Down 1, 2, 3, 4, 5. And of course on graph paper this is much easier. Okay. All right, before I connect those dots in a nice exponential growth curve, what is my horizontal asymptote? Yeah, right here, always, always, this last add subtract number there, y equals -5 is my horizontal asymptote. I'm going to draw that in first. 1, 2, 3, 4, -5. Draw that dashed line. Horizontal asymptote. Yes, well.
Is the asymptote always the last?
It is always, always this last add subtract number, whatever that is. And then I'm going to go from my asymptote and up to the sky. And there's my great curve. What's the domain? Negative infinity to positive infinity. Very good. Domain is how far left and how far right those arrows go, left to right. They go forever. They extend in both directions. What's the range? How low does it go? How high does it go? Good. Our lowest y value is down here, very close to -5. Extraordinarily close, atomically close to -5. Okay. And it goes all the way up to positive infinity. Okay. Questions on this one? Is this very much like the exact same process as yesterday?
Yes.
Yes. Kind of nice, right? This number in front stretched this taller. That's what it does. It spreads these points up more. Makes them bigger. Okay. Let's look at letter B. We have f of x. So I did have some questions. F of x is just fancy language for y. Same thing. F of x equals -2 times 1/3 to the x plus 2 plus 4. What should we do first? After I box the base here, box your base, what does the x plus 2 do to the curve? Left. Very good. Left 2. Remember, this 2 is inside with x. Those parentheses are containing it, saying it moves in the x direction. So it only moves left or right. In this case, it's moving left 2. What's the plus 4 do? Up 4. Very good. Okay. Excellent. Let's go back to our base. I'm going to do a sideways XY chart this time. We want to be able to be flexible. What number should I use for x? 0 and 1. Excellent. And so if I take a 0 and plug it into my base here, I have -2 times 1/3 to a power of 0. Take a second and write down what you think that is. All right, what is it? -2. Very good. 1/3 to the 0 is 1, and 1 times -2 is -2. If we plug in a 1 to our base here, -2 times 1/3 to the first. Take a second, write down what you think it is. All right, what do you think it is? Negative 2/3 is very good indeed. Maybe you're not sure, that's okay. This is why we have calculators, ladies and gentlemen. I can type in negative 2 times 1 divided by 3 raised to the first power. It gives me a crazy decimal. Can I use the decimal? Sure you can. Negative 0.666. Maybe you don't want to use the decimal. What could you do? Math bracket. Math bracket. And we get negative 2/3. All right. So let's do a little graphy poo here. 1, 2, 3, 4, 5. 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm so glad you laughed at that. That's hysterical. Okay. All right, I'm graphing 0, negative 2, big orange dot. And 1, oh, where's negative 2/3? It's between the negative 1 and 0. Is it closer to 0 or closer to negative 1? It's closer to negative 1. Very good. It's a little closer to negative 1. Ladies and gentlemen, is this exponential growth or exponential decay?
Decay.
Decay. Right here, our base is 1/3. That would be a decay value because it's between 0 and 1. So this is a flipped decay function. So it's decaying closer to that horizontal asymptote. Now we're going to shift it. And we're going to shift these orange dots how? Left 2 and up 4. So left 1, left 2, up 1, 2, 3, 4.
Wait, what's that? F times the x?
F of x, F of x, and it's just a y. It's just fancy. It really means a function in terms of x, meaning, hey, look, there's an x in it. I'm going to take this other dot here and again move left 2 and up 4. Left 1, left 2, up 1, up 2, up 3, up 4. What is our horizontal asymptote? Good. Y equals 4. I'm going to make sure I draw that in first. Got my horizontal asymptote at 4. And I'm going to decay towards that asymptote. All right, domain. How far left and how far right does this graph go? Negative to positive infinity. Good. All right, now for all the money in the world that I possess. I'm just kidding. So, range asks, how low does it go? What is our lowest y value here?
Infinity.
Negative infinity. Very good.
No, it would be 4.
And then how high is it?
4.
4. Very good.
Get the money?
Very good. All right. Do you need to do another one? No? Okay. Hey, will you please graph this in your calculator? Since we have them out, will you go to y equals? Go to y equals, and let's type in the entire function, negative 2 times 1/3 raised to the x plus 2. And we need an arrow to the right to get it down. So arrow to the right, and then you can do the plus 4. And then when you get that in there, you can press graph. Is anyone not working? All right, I'm going to show you one more thing. All right, this point right here, I believe I have as negative 2, 2. Do you see that point right there, negative 2, 2?
Yeah.
Okay. We can actually check it using our calculators. Rebecca, your calculator does it too.
Yeah.
There is a trace button. So trace, ladies and gentlemen, on your calculator you have a trace button right here. Well, you push trace,
Whoa.
and then you're going to type in x equals, or you're going to type in negative 2 because that's our x value we have there. We're going to type in negative 2 and hit enter.
Oh my god.
And it tells you, hey, what's the y value? 2. Yay, we checked our ordered pair. We're totally correct. Did anyone not see that? Trace is a very cool thing. If you're graphing on your worksheet and you're like, what does this look like? I'm confused. What can you do? Can you graph it on your calculator?
Yep.
Yeah. When in doubt, Greg, use your calculator. Yeah, graph it out. When in doubt, graph it out. All right, ladies and gentlemen, I will pass out your short worksheet.